Good morning and welcome to our Red Short webinar. My name is Mac and today we're discussing EnemyBot Malware. As always, you can find information on related topics at redskylines.org. If you missed any of our previous Red Shorts, you can find them on our website. In March of this year, researchers with FortiGuard Labs identified EnemyBot, a brand new, rapidly evolving Linux-based botnet. At first glance, and by analyzing the initial infection, it appears to cover a wide range of devices and platforms. Threat actor group KEXSEC is believed to be behind the distribution of the malware. What's worse is EnemyBot's source code can be found on GitHub, giving any bad actor access to its tools and able to craft their own outbreaks of this malware. The initial infection was identified making drive-by attempt to shell at a web server with an interesting payload attached to the value string. Several attempts to download an update.sh file using different methods. Taking a closer look at the update script, the malware attempts to download 13 different binaries, each compiled for different system architectures. The architecture type is appended to the end of the name EnemyBot. Given the wide range of supported architectures, at first glance, this botnet should be effective against Linux-based hosts for 24 vulnerabilities in VMware Workspace 1 access, WordPress, Adobe Cold Fusion, plus various IoT and Android devices, just to name a few. These security holes are mostly used by the malware to spread from infected machine to machine. The first section is a Python script used to download all dependencies and compile the malware into different operating system architectures. After compilation, a batch file is created and used to spread the malware to vulnerable targets. The second section is the main botnet source code, which includes all the other functionality of the malware, excluding the main part, and incorporates source code of the various botnets that can combine to perform an attack. The third module is obfuscated segment hide.c, and is compiled and executed mainly to encode or decode the malware strings. A simple swap table is used to hide strings. The last segment includes the command and control component to receive vital actions and payloads from attackers. Also incorporated is a scanner function that's engineered to search random IP addresses and associated with public-facing assets for potential vulnerabilities. If an Android device is connected through USB or Android emulator running on the machine, EnemyBot will try to infect it by executing shell command. EnemyBot appears just getting started to spread. However, due to the author's rapid updates, this botnet has the potential to become a major threat for IoT devices and web servers. EnemyBot obfuscates strings in a variety of ways. The C2 domain uses XOR encoding with a multi-byte key. Credentials for brute forcing and bot killer keywords use Mirai-style encoding. Commands are encrypted with a substitution cipher, i.e. swapping one character for another. Some strings are encoded by adding a 3 to the numeric value of each character. While these obfuscation techniques are simplistic, they're sufficient to hide the telltale indicators of its presence from casual analysis and other botnets. Most IoT botnets, including EnemyBot, are known for searching for such indicators to terminate other botnets running on the same device. In terms of spreading, EnemyBot uses several methods that have also been observed in other IoT botnet campaigns. One way is using a hard-coded list of username password combinations to log into devices configured with weak default credentials. This is another module that was copied from Mirai's source code. So how does an enterprise protect itself from this malware? Ensure systems are fully patched and not vulnerable to RCE. Reduce the exposure of Linux servers and IoT devices to the internet. Use properly configured firewalls, enable automatic updates, and monitor network traffic. Patch IoT devices firmware to the latest versions to mitigate external exploitation. Employ the usage of Layer 7 network monitoring and detection to detect common exploits that may leverage RCE. Ensure that externally exposed network segments are isolated from internal hosts. Disable or limit execution from Linux TMP directories. All right, that's all for today. Thanks for joining us. I hope you enjoyed the material and found it useful. If you have any further questions on the subject, you can contact us via Jim McKee. If you're not a Red Sky Alliance member yet, please sign up in our portal, redskylines.org. Membership is free and will give you access to a variety of Red Sky Alliance content. Have a great day, and we hope to see you again next week.